I am R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this video, we are going to discuss the topic Transverse Electrics and Transverse Magnetic Waves for the course Transmission Lines and Antennas. So, we can relate from this diagram as left side we have an oscillating wave, and the right side we have electric field and magnetic field. And electromagnetic waves are classified into two types. One is TE waves and another one is TM waves. So these are based on the direction of wave propagation, and in TE waves Ez equal to 0, but Hz not equal to 0. So we have the fields Hy, Ey and Hx, but Hy and Ex are equal to 0 because they are having the value of Ez. So the wave equation is taken, and in the wave equation dou squared by dou y squared is 0, and dou squared by dou z squared is substituted as gamma squared because we have taken the parallel planes. Parallel plane is constant in y direction, so dou by dou y is 0, dou squared by dou y squared is also put to 0, and in the wave equation dou squared by dou z squared is substituted as gamma squared because z direction is the wave propagation direction. So we can make equation 1 is dou squared by dou Ey by dou x squared plus gamma squared Ey is equal to minus omega squared mu epsilon into Ey. So this right hand side term brought into the left side, and combined, the second and third terms are combined, we get dou squared Ey by dou x squared plus h squared Ey equal to 0, and this Ey field is taken as Ey0 e power minus gamma z. Here Ey0 is the magnitude of electric field, e power minus gamma z is the phase value. So by substituting instead of Ey, dou squared Ey0 by dou x squared plus h squared Ey0 equal to 0. And equation 2 is the differential equation, and its solution is obtained as Ey0 is equal to C1 sin Hx plus C2 cos Hx. Here C1, C2 are arbitrary constants, and showing the variation in z direction, we get Ey is equal to Ey0 e power minus gamma bar z. And so in C1 sin x plus C2 sin Hx e power minus gamma bar z added. So now we have to find out C1 and C2 values from the boundary conditions. So boundary conditions for the parallel plane, since parallel plane is of perfect conductor, here we have taken. So for all values of z and time, the tangential component of electric field is 0. So this is the boundary condition. So we have to make Ey 0 at x equal to 0, Ey 0 at x equal to a for all values of z, that is at the boundary, that is x equal to 0, x equal to a, the tangential component Ey is always 0. So now we are applying the boundary condition 1, Ey is 0 at x equal to 0. So we know Ey is C1 sin Hx plus C2 cos Hx. By substituting x equal to 0, we get C1 sin 0 plus C2 cos 0. We know sin 0 is 0, so first term made 0. So Ey is C2 only because cos 0 is 1. So C2 must be 0 in order to satisfy the first boundary condition Ey 0 at x equal to 0. So now we found the value of C2 equal to 0. So by substituting C2 is equal to 0 in Ey equation, Ey will have only the first term, Ey0 is C1 sin Hx, because in the second term C2 is equal to 0. Now applying boundary condition 2, Ey equal to 0 at x equal to a, Ey0 is taken as C1 sin Hx. In order to make Ey 0, H must be equal to m pi by a. So H is equal to m pi by a for m equal to 1, 2, 3. We get Ey is C1 sin H m pi by a into x e power minus gamma z. Other fields are obtained, and now Hz value is obtained as minus m pi j omega mu a C1 cos m pi by a into x e power minus gamma bar z. And here the mode is T m0 mode, and because for each value of m there is a particular field configuration, the associated wave is known as T m0 wave or T m0 mode, and Hz is obtained in the similar way. So Tm wave H equal to 0 we have to put, and Hx Ey is 0. In the basic field equation we have Ez Hx Hy value. So boundary conditions are obtained and final answers are obtained. So these are assessment questions. The wave in which the component of electric field absent in the direction of propagation is known as H waves, and the wave in which the component of magnetic field is absent is called transverse magnetic waves. And the value of waveguide propagation, the value of propagation constant is equal to C. And what is the boundary condition for a perfect conductor? Tangential component of electric field is 0 at the surface of the boundary condition. Thank you.